So thank you for giving this chance. And Dale and I did not prepare to speak for this, but I think these will be two very complementary discussions. So today I want to talk to you about the Iron Triangle. And some of you know the Iron Triangle, but to be very explicit, I will define that terms. But before I do that, I want to talk about the fact that when I was in high school and middle school, I was a voracious reader. It's been really copying that. So ADHD, I keep just funneling info in my brain. I read as fast as I could. One of my favorite science fiction authors, I read all the classics, but the ones that really spoke to me were books by David Gibson. And if you talk about William Gibson, you know him for the fact that he's the first one that invented the term cyberspace. And he helped truly define the genre of cyberpunk. And so there's a William Gibson quote that I really like, which is, future is already here. It's just not yet being distributed. So keep that in mind as we go through the next few minutes together. So this is the Iron Triangle. That's cheap, good, two. You can never optimize for all three of these things. If it's good and it's cheap, it won't be fast. If fast is good, it won't be cheap, etc. And so you're certainly familiar with this concept. And so what I'd like you to think about is you approach machine learning, gadgets, digital data collection, AI, all of these tools, this iron law still applies. So our expectations in life have changed. So over here in black and white, you see what a gold medal ball looked like in 1932 versus what it looked like in 2012. And in science, our expectations have changed as well. So in 1974, Howard Moskowitz published this paper in Science showing that liking is not a monotonic increase. It's not just a straight line, it's a shallow inverted J. Well, if you fast forward today, you want to publish a paper where you just a routine journal that's not one of the most prestigious in the world. You have to model a pharmacophore and show which sweetener finds which pockets on that, and model synergy and show what's going on. So our expectations in science have changed as well. So John Stabler was a meat science professor at Penn State, and he was doing case class back in the 1960s in these labs where they keep dating. And these are hand-drawn ANOVA tables from his archives. So I know that nobody under the age of 40 or 50 can even read that cursive. So Gen Z, I'll apologize. But what we can see the errors are on the left. It says between cuts. It says between analysts. So he's actually hand calculating how that ANOVA. So think about how long that was taking. And then in the 1970s, all of a sudden we had mainframe computers. And you could now calculate an ANOVA in minutes instead of hours. You still have to walk over to the computer center. So that might take days to get the job processed. But the day actually ran quite quickly. And then came the personal computer revolution in the 1980s. And now all of a sudden you could afford to actually have a computer at your own desk. And this caused massive productivity because now you can calculate those ANOVAs in seconds. And in fact, today, you don't even have to write the code yourself. You can go to Copilot and you can say, give me the SAS code for a taste test. And then it'll help to explain to you what that code is supposed to be doing. So now we've gone from hours to minutes to seconds. So we can do things faster. But it doesn't change the fact that we're still asking the same fundamental question. Are these products different from each other, or do we use a mathematical model? The same thing happened with time intensity. Here's the famous 1978 paper for Gross Breeze. I'm looking at that's a chart recorder. So again, for anyone under the age of 50 or 60, there's two spindles of paper that a motor moves across that table. And then normally you would hook this up to an electrical signal, and that plotter can move up and down, and you create a line trace on that. Well, the innovation here was to actually have analysts move that stylus up by hand as the chart recorder advances. So you get time intensity curve in an analog manner using a piece of paper. So that event technology to the rescue, you had the mini computer era. Here's a Tech 11 that Harry Lawless found in a closet at Natick, where the soldiers were using this as PCR. So that's your tax dollars worth. And Harry knew Fortran, so he actually went and he wrote custom code so that he could do time and sensitive data, digital data flash in the 1970s. And then if you go to the 1980s, what we can see is again the personal computer readiness. So this is something you could do at the desk. So over there on the right hand side, those are game outs, like Palm on your Apple IIe. And somebody figured out that you could actually use these to flex intensity ratings for time intensity data. And you'll see the samples were introduced to time zero, evaluation ended, and dashboard returned to zero problems. Swapping, the judge rated each attribute, or notice they did this separately for each attribute. So it's 4 runs to get efflux. So it was single attribute time intensity. But judges felt comfortable with the method once we led to it just once. So there was a little bit of warm up, but people could adapt to this way. And then today, we can talk about things like our data processing. So how do you integrate the area under the curve when you have a double peaked curve? Well, you ask a graduate student if they can write custom Python code, and then you can actually start to look at things like time and sensitive curves that have more than one shoulder in it. So with that, I want to enforce this idea that technology is great. It makes us do stuff faster. It can save us money. So that's a great upside. But we always have to be skeptical. We need to be incredibly skeptical. There's so much hype. There's so much money to be made. So I'm sure you're.
In a stunning development, Canada has declared war on the United States. Let's go to Joe Braxton, who is live at the border.
I'm currently at the border, but there is no war. Mom, Dad, I know this looks kind of real, but it's all AI.
Grandpa, I'm fine. This is just AI. You don't need to wire money to anyone. I am not in love with you. And I do not need your money for a plane ticket. I am AI.
This fake moon landing footage isn't classified. It's AI.
You're probably wondering how I got rich with crypto.
The truth is,
I didn't get rich off crypto.
I don't even exist.
You might be able to tell this is fake now, but it's gonna keep getting better.
We're all AI.
There could be aliens, but I'm not one of them. I'm AI.
An herbal supplement did not cure my cancer. I'm not even real.
Uncle Fred, the government has not been taken over by lizard people.
You don't need to send us $5,000 in gift cards because you missed jury duty.
Grandma,
It's not real.
it's AI.
It's AI.
It's AI.
It's AI.
Bro, it's AI.
Fake faces.
Real consequences.
Think before you trust.
I appreciate the message of this video, but it was all made with AI too. So can we even trust it?
It looked pretty real to me.
This is a video this individual posted to YouTube back in May. Hired about his culturally relevant insurance about Facebook. So it's not just your uncle that gets told about Facebook. So here's 2 of the leading thinkers on ethical use of technology in the 21st century. And this is a quote of theirs that I love, that in the war between humanity and AI, Aristotle spoke on the social media algorithm in humanity lost. Right? We all know that much of what we're dealing with today, in terms of the global political climate, is due to disinformation that's been enabled by these technologies, and the radicalization of millions and millions of people is really due to an algorithm that is rewarding encouragement instead of a positive community. So AI fraud is not just pulling your umbrella like Facebook. Let's draw your attention to this paper article. It's entitled "The Influence of Perceived Spiciness on an Actual Case Experience Experimental Study." You can see here the opening paragraph says, The perception of sensory experiences, such as taste, complex processing with myriad factors, including physiological, psychological, and contextual elements. For reference, one aspect is received less attempts in the literature's information or expectation on sensory perception. I can't agree with that. They can reference. In this study, we focus on perception spiciness and sensory experience is particularly susceptible to individual differences in contextual factors. And here are the references. So, Don Prescott's paper entitled Multiple Contributions to Food Perception. There's one from Rogeris and Al, and then there's one from Nigars and me. However, none of those papers exist. Those are all fake references. The LLM that was used to write the introduction to this paper was smart enough to pick out the right people in our field and come up with convincing sounding titles and fake references in this lit review. And then the other thing is I would point out this, of the 19 people that supposedly peer-reviewed this book in peer review on this website, many of them were critical of the experimental design is absolutely garbage piece of study. But only one person even commented about the references, and they didn't even explicitly notice that they were fake. So be skeptical. It's coming for sensory. So my first lesson, the end of Act 1, is to be very, very respectful. So some of you know this phrase, the Ronald Reagan made famous. It was actually a Russian phrase first, which makes it extra ironic, and I would like to update it for 2025 by saying don't trust and verify. But I would also like you to continue to play with these tools because I made that animation using AI. So I just went into Claude and I said, hey Claude, can you make me an animation? And it said, well, I can't do it that way. Oh, but this might for you. Let me do that. See, that's, and it gave me this management. Okay, it looked like the old-fashioned tree war that goes through. And so it took me under 3 minutes to make that animation. So in Act 2, I want to tell you about the importance of training data and implicit assumptions. And so we're going to look backwards to do that. And so in the 1950s, Kodak really revolutionized color photography by making it very affordable to the masses at a massive monopoly actually on political technology in the United States. And you could get your photos processed, used to drop them off with the photo map, pick up 84 hours or 72 hours or a week later, and you print all your pictures for you. And to do this, they actually had color matches every single one of those because what happened is that Kodak in Rochester, New York, would actually send out masters of what the pictures should look like. Every time they look at the chemicals in a new batch of paper into that photo printer, there would be lots of variation. So the photographer, that local photo map, would then go and print out pictures and fiddle with the knobs on the device. So the picture that came out looks like the reference image that Kodak had sent them. And these are known as Shirley bars. So this is the earliest known Shirley bars that you can find on the internet. We don't know why they're called Shirley bars, other than there was an employee named Shirley. And Shirley has a certain aesthetic, certain 1960s American standard of beauty. You can see the original Shirley left the company shortly thereafter. We don't have a picture of the original Shirley, but Kodak kept producing Shirley bars for the next 40 years. And so here's a 1974 Shirley bar, here's a 1980 Shirley bar. Love that haircut. But you can also see like the gray, so you can get the color balance correct, and as a colorful image, etc. And this is what an actual Kodachrome photo from 1974 would look like that I found on Flickr. And it was shaped Jeremy created commons lesson, so I really appreciate Walt putting his historical pictures out there. So this is what a real picture would look like taken on Kodachrome film in the 1970s. But I also want to show you there was a known problem with this film. This is from the same photographer. You'll notice a distinct problem. The film chemistry here has been optimized for white faces. You lose all the nuance in the faces of everyone else in this picture. And so Kodak knew this was a problem, but it took them a while to fix it. But they did actually in the 1980s. They introduced Kodachrome 200, and they came out with Kodak Gold in 1987. So they revolutionized their film chemistry to finally update to see what caused this problem. Then the other thing they did, with the very 1990s multiculturalism, they mapped it with a multicultural problem. And again, there's that those. So we know about students right now, right? This is well known in the photography industry. Well, guess what? We still have this problem today. So in 2009, there was a question over whether the Nikon Coolpix was a racist camera. Because Josh Ryan is playing with her mom's new camera at an LA doctor's game in 2009, and the blink detection feature after her eyes were closed. And so you're thinking, okay, response in the training data, but really we should be able to fix this. Well, of course, the internet being what it is, triggered by reality, people use Photoshop to make fake versions and cause outrage. So there are real versions and then there are fake green, fake photographs. But it doesn't get better, because then in 2009, HP computers were racist, went viral on YouTube. And so what you can see is that you can't get the webcam following around the office. Where Wanda, it follows her. And so that Consumer Reports actually validated this and confirmed that the effect that they reported on YouTube was real. But they also showed that it ended the quality of the camera and the lighting. So it wasn't under all possible conditions. So again, the testing conditions and the implicit assumptions about who you're making your product for matter. 2016, Richard Lee tried to upload his new headshot to the New Zealand government website to view his passport. It rejected his photo because his eyes were closed, according to the website. And then I think probably the scariest of this is for those of you that use Lensa AI to make a little cute little avatar of yourself. Well, in December 22, this journalist decided to make a Lensa avatar of herself and pornified her. You can see there, for those of you who can't read it back, it says, of 100 avatars generated, 16 were topless, and another 14 entered skimpy clothes and sexualized poses. Because these models were trained by scraping the internet, and the internet is accessible. So, lesson number 2, we need to actively work to erase bias and assumptions. So when I was 11 years old, my mom and I sat in a photo booth and took pictures. And so, as a default upstate New Yorker that grew up an hour and a half from Kodak, that film was optimized for people who look like me. But most of the people in this room don't look like me. So we need to keep that in mind as we're thinking about how to reduce these biases. So like amateur psychologists for just a second, I want to tell you about the false consensus bias. That's where we overestimate how much other people share our own lived experience. We overgeneralize from what we know of our own lived experience. I also want to say about algorithm bias. That's when algorithms are not trained with diverse enough data sets and or tested accurately across different demographic groups. So that you get these biases. And my brother-in-law, a computer engineer, says, oh, well, it's not racist, it's just bad training data. And is that really cool? Right? So if we don't use appropriate race, we have to have a human in the loop, as we heard the other day. So some solutions that we can think about is have diverse and representative teams, because more perspectives cover our own blind spots. I have blind spots. When I was doing work on vaginal suppositories, I had lots of blind spots. So I needed to trust my team so that when we were talking about these products, we could get a holistic impression of those products. Use diverse and representative data, so which are training data set, very demographics and perspectives built into them. Monitor them, so we need to audit things to make sure that after we deploy them, that we can pick up emerging biases. Then we have to have human oversight. As I said, keep a human in the loop, especially in business cases or legal cases or ethical cases. So don't just trust the AI. And that doesn't mean we shouldn't use these tools, right? Iron triangle, that's your cheaper, better. Too. Here's a study we did with COVID with some of the people in this room. Thank you for your help in this collaboration. We worked on this project with Nolan Meyer at IBM, and we did a natural language processing of open comment boxes, patient verbatims about that COVID sentence. And we were actually able to show that just by processing people's self-identified COVID symptoms in a text box, we were actually able to come out about chains. And so we did this with a large language model, working with the world expert at IBM. Fast forward a year later, everybody could do this. Because OpenAI launched, Anthropic launched, and Microsoft launched very quickly. We iterated extremely quickly, and then large language models just burst onto the scene. And then in May of 2025, Copilot added image integration. So I made this logo in 90 seconds in Copilot. Is it fast? Yes. Is it cheap? Yes. Was it good? No. But don't be afraid to play with these tools as long as you keep allowing it to have attention. So the question I'll answer you is, will widely available natural language processing? We talk about who's actually paying for the processing over time. Well, let's assume that for most people, it's cheap and it's something they can get. We'll secure a pilot from Microsoft to write out a HOT, one AP, or whatever it is. I don't have to talk in that. Does it make all data scalable? And so at the SSP meeting last year, I was having a discussion with Mike Menstrid that was inspired by Mike to go home immediately and share out my labs for my undergraduate class. So I completely invented a new lab, qualitative research methods with AI-assisted analysis. And so step one was to come up with a product concept. So this is a class taught to first-year graduate students and fourth-year undergraduates. And so we come up with a product concept. And then I had them use AI to come up with a moderator guide, which you can do in about 30 seconds. And then I had them review the moderator guide, clean up the moderator guide, and file the moderator guide by hand. Then I had them conduct a focus group by playing an overnight state break on Zoom so that they could get a auto-generated transcript of it. Then I had them summarize the transcript manually, pulling out the key thematic elements that emerged. And then I had clean the type scan out and anonymize the transcript and feed it into ChatGPT or another LLM of their choice. And then I even told them what prompts to use. And the prompt was, please analyze this script transcript and identify 3 to 5 themes regarding consumer reactions to product concepts. For each theme, provide a brief explanation and supporting quotes from the transcript. And then write it from the note, summarize. This is what my students had to do. And so the questions they had to answer were, compare the AI-generated moderated guide with a polished one, compare the video versus AI thematic analysis, reflect on effectiveness, and pros and cons, discussing the ethical issues. And so these are some of the student verbatims from that level. The AI was effective, but I think being in a conversation to see facial expressions and hearing their tone when they talk is also valuable to understand the key takeaways. AI has an admitted visibility to older estimates and takeaways based on words, while humans can be more in tune with body language and general attitudes. Once during this speed, the quotes used where AI was not actually anywhere in the transcripts. The AI paraphrased some of the points instead of the direct language even after the transcript was cleaned up. Some quotes used were not even close to the original lines, such as when asked what Pangborn spice was, Bruce Smith said, I don't value spice, it's not a Kate Neal spiciness. AI changed this to, I prefer a milder version, I think of it a little more. So it will completely hallucinate your ratings. My biggest ethical concern is the inability to pull correct quotes if someone randomly added transcripts without double checking they might not catch this error. And then last, the moderator guide didn't really focus on the things I wanted it to focus on. And AI might suggest you do illegal or unethical. So then diving deeper, one student in particular, first year graphics, she wanted to make a women's health-oriented food product, snack product that would help with menstruation and perimenopause. And so this was her product brief that she submitted. The company was looking to develop a female voice snack towards women's health. She talks a little bit about some of the ingredients, and then she conducted an actual focus group with organic members who were aged 22 to 58, so it was convenient to sample remote effects. Her takeaways for chemists not left form, do a candy instead, the functional attributes of supporting menstrual health, fertility, final function were major drivers and interest, which is menopause was also expressed. However, she noted that AI did not pick on some of the minor details from sessions, like specifically me, that it was a female. In other words, that AI assumes this was about general health and it completely degendered the prompt. And the nerf's analysis completely ignored who this prompt was actually meant for and is as big as possible. We don't know why that, right? These are black boxes. Is it, so when I say nerfed, the foam guns where you're on and you shoot your friends, that's nerfed. So nerfing the world is when you put rubber bullets on it. So the fact that they nerfed the output by trying to make it innocuous, not offending one, they actually stripped all the value out of the analysis. Or is it biased training data created by software engineers who don't care about it? We can't know that. So in the last part of my talk, I want to talk briefly about some new exciting work by some colleagues of ours. Back in 1980, Harry Dislev published this paper and built this amazingly complicated contraption to measure real-time eating rates. So every time you pick up the spoon, you would weigh how much food you would eat. So we could actually get real-world data on how much people eat. However, this meant that besides being impossible to build, had lots of problems. You could only measure a single food. You couldn't measure multiple foods. It was highly sensitive to vibration, so they had to do all these things to get you to not lean on the scale, to put the spoon down before you gently, they had a big spoon holder, and then they had all sorts of really complicated instructions. You must not touch, remove, or disturb the bowl or the spoon. Please do not disturb the bowl. They really had to be customized. Then about 25 years later, Martin Yeomans invented a similar thing in Sussex. When I started as an assistant professor at Penn State in 2009, I called up Martin and I said, can I buy one of yours? He said, you don't want one. He said, it's just too noisy. So now we're on 3.0. So before I get to that, I want to talk about the current state of the art in measuring eating intake. So Matty Harper and Gage Cunningham, who we heard from the other day, spent hours and hours and hours watching video coding, and so we watched these people chew. We thought dots by people understanding chew, they don't do the dots. They just think people are funny. And then so your students will sit there and watch these videos for hours and hours and hours, and every time somebody chews, they press the space bar, and every time someone bites. And so it's incredibly labor intensive. But we're writing big trucks about being able to measure this with digital adaptions. So one way to approach this is using rules-based machine learning, but we can also use deep learning, so we have two different approaches here. Again, I don't have a dog in that fight, which one we're gonna do. Is it better just to have deep learning watch lots and lots of videos and figure it out? Or is it better to say, here's spatial landmarks? And here's an example from some of our Dutch colleagues showing how this works. So you can actually just feed this in the algorithm and it'll actually count all the times they chew by using spatial landmarks. And so if we return to Harry Dislev's food weighing scale, we can see the same sort of thing. So now we actually have a single kind of device using modern electronics. There's 3 different pressure sensors, one in the top left, one in the center, and one on the right, so you can do multi-component wheels. And as we watch this person eat over time, what you'll see is there's those giant transient spikes when you put food that too much pressure on. So all those artifacts in the old days can be in my hand. But we can also see there's an example that's about to come up. The person's going to take a double bite. They'll take a bite, then go to put it down, right now, put it all the way down, take a second bite, and then put it down. So we see these giant excursions of these data. And the advantage now is that, and so now we can get data from people's real-time eating behavior, and then use algorithmic approaches to this. So this is a multi-step process where you're looking at all these excursions, so you find them weight stable, and you would take out all the spikes, you filter the period between those periods, and then now we can identify each bite as a weight difference across time after you remove the spikes. So there are ways to optimize this process. So we absolutely need to use these tools because faster, cheaper, better paid. Okay, so my lesson 3 is AI and tech will not pay for you. It cannot replace good research specialty, good turnaround time, it can deep direct data. But it might get you there faster or cheaper. So some take-home messages. These are just a tool like anything else. A notebook went from hours to minutes to seconds because of tools. Time intensity went from hours to minutes to seconds because of new digital tools. I do not think these tools are anything fancier than just allowing us to do good sensory science for you and PhD faster, but not necessarily faster. So be skeptical, requested the assumptions that are in these data sets. These may be a game changer for both all data by making it scale, because now all of a sudden it will be like things much faster instead of spending weeks loading focus groups manually. We can do it much faster. And then overplaying blind data is even more faster. So whether we like it or not, many millions of Americans are living in an AI-mediated world. It's probably like one of my grandchildren will fumble and be dating with artificial intelligence, and they'll be like, "Well, bigot, I say that evaluate person." So, with that, I will happily take any questions, and I will also point out for those of you that are interested in overall processing, we are hiring an assistant professor or an associate professor who are processing. The search is open right now, so please come and verbally see with us.
Thank you, John.